I'd like to introduce Dr. Rayid Ghani to kick us off today for the Secure and Ethical AI track. Dr. Ghani brings a really unique perspective at the intersection of AI and public policy. He's currently professor at the Carnegie Mellon University in both the Computer Science School as well as the Hines College of Information Systems and Public Policy. Before that, he was in both schools as well at the University of Chicago and served on Obama's 2012 presidential campaign as chief data scientist. So, Dr. Ghani, the floor is all yours.
No, thanks for having me here, and you know, I wish it could be in person because I'm sure nobody wants to sit in a room with all the other people watching people like me on a screen. So it's unfortunate, but you know, well, I'll try to be hopefully useful. My plan would be in the next sort of 15-20 minutes, try to give you kind of a breadth first view of how to design. Pick your favorite buzzword, machine learning, AI. You know, I don't really care about those buzzwords that help us get to equitable outcomes. That's kind of, so it's going to be a very breadth first view. I'm not going to go into detail in any one area. There are more details about everything I'm talking about, so I'm happy to follow up with people afterwards, give pointers, papers, list of tools that. So that's kind of the intention. I want to sort of start by just to get people where the kinds of problems that I'm focused on to kind of give you some context. So a lot of my work is working with government agencies, nonprofits, on helping them design, again, AI, ML systems that are helping them tackle kind of important policy problems. And so this is one example, which is dealing with the criminal justice system that is horribly broken in lots of ways in this country. And this is just, these are some numbers for U.S. jails. 11 million people go through the jail system in this country. And yes, it spends a lot of money, but more importantly, most people in the system suffer from mental health illnesses and substance abuse disorders and chronic health problems. And because of that, they end up cycling through the system over and over and over again. And so some work we've been doing is working with some of these organizations to help them figure out how do we prevent people from coming through the system over and over again. And in one case here, this is with a county in Kansas, they were trying to be proactive about providing mental health services to people in order to reduce jail recidivism. The challenge they faced were two challenges. One was they had limited resources to focus on the people who needed the helps. And so one was that. Second one was they were struggling with trying to figure out who do they prioritize. And so they came to us to help in trying to figure out how do we allocate resources towards people, not only for people who need mental health services, but also people who will benefit from it by reducing their risk of going to jail. So over the last few years, we built the system to connect all this data together, from mental health to criminal justice to police to homelessness to other types of, put it all together. And step one, right, link all the data together. Step two, build a system to predict or to identify people who have mental health needs. Three, identify those who are going to a high risk of coming back to jail. Now, at that point, if we were focused on just the machine learning for the sake of machine learning, we would stop and say, hey, we can accurately predict who's going to come back to jail and has mental health needs. That doesn't help anyone. We just now can watch these people come back to jail. So then what we started a randomized control trial about 3 years ago that was designed to test whether the people we identified, whether they are helped, whether their risk of going back to jail reduces because we intervened on them. So over the last 3 years, we've been giving the county a list of people, the mental health team, to intervene on, where they go in and provide them mental health services, and measuring the impact of that on a variety of outcomes. And so far, we're finding a few different things. One, it's reducing the arrest rate of people. So it's gone down by about 25% on the people we intervened on. It's reducing the number of jail bookings they have. It's reducing the amount of time on average people spend in jail, about 30%. That's to the side of criminal justice. On the mental health side, we're finding two things. One, they are using the mental health services system more, so they're consuming these services, which is good. And more importantly, their use of emergency services, 911 calls and ambulances has gone down, which means they're now into the system and are less relying on emergency things. So that's, super encouraging for us. And the second thing we looked at was, are we benefiting everyone who we're identifying, or are we leaving certain people behind? Who are we most impacting? And we're finding in that case that we're actually, the people we're most improving outcomes for were the people who were highest risk of going back to jail, which is not only surprising, but extremely encouraging. So that system is now deployed, and we're kind of working on expanding it in a number of different directions, right? So that's kind of an example. It's a pretty typical example of a project that we do. A few other examples over the last few years. We worked in this case with the Chicago Health Department to help them. Again, the way they dealt with lead poisoning in homes was they would wait until somebody had lead poisoning and then go try to fix the problem, which is pointless because lead poisoning effects are irreversible. So we helped them build a system that predicts when the child is, a month, 2 months old, before they get lead poisoning through paint, who's at risk, and then proactively give them the tools to then go and do these prevention inspections and remediation things. That system, again, randomized control trial, and is deployed in Chicago. This is a project we started recently in Baltimore on identifying roof damage through aerial imagery, to, again, help the city figure out where the roof damage is so that they can go and again, do proactive inspections to then do safety and stabilization efforts. Another recent project was with Mexico around 40 to 50% of the kids we were looking at, with the states we were working with, didn't get vaccinated in time for a lot of regular vaccines like MMR and polio and things like that. And we helped them build a system that would identify, again, give them an early warning system to identify which kids are unlikely to get vaccinated in time, so they could then focus their efforts towards getting those kids vaccinated. There are many, 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 many more projects. So if you're interested in looking at it, there's a link here that you can go into, and they span sort of different types, different cities, different countries, different types of focus areas. And so, kind of the way these projects structure, they're kind of three characteristics generally these projects have. One, that they're not making autonomous decisions. They're helping people make critical kind of policy decisions about people's lives. Not policy with a capital P, but kind of policy at a small p, I call it, right? Where we're making lots of decisions about who to intervene on, when to intervene on them, how often, with what type of intervention. And so they're helping people make decisions that are critical. Two, they have the real sort of the unfortunate but real setting of limited resources. They need to help this many people. They have the unfortunate reality of having this many resources. So they have to sort of figure out how do they allocate those resources. And that limited resource scenario leads to them making choices about equity and efficiency and effectiveness, right? So in the case of the mental health services, this many people need help, and they have this many resources. So if they design systems that maximize the number of people they help with their limited resources, it's basically efficiency. And if you design a system to do that, you're going to prioritize people who are cheapest or easiest to help. Now, that's not bad, but it's at the expense of possibly leaving behind people who are harder or more expensive to help. And that creates inequities, right? So there are these implicit choices that are in there. And when they're designing these systems, both human and machine learning or AI systems, they have to make those value choices. And so the way we've been thinking about it is, how do we develop these systems that help people, humans, make these decisions that lead to fair and equitable outcomes? So the way we view sort of our design process for these machine learning systems is, the goal of these systems is not to predict X or to be as accurate as possible, but really more about what are the values we want the systems to help achieve. And so we start with the process of coming up with these values, including different community members, people who are going to be using this, people who are going to be impacted by it, people who are designing it. And we first come up with the values that we need to achieve. And then we build it to achieve those values. And then we have to validate and monitor it so that it continues to achieve those values, right? So it's kind of a different starting point than saying we need to build an accurate system that does this. Well, accurate means what? Correct for most people. That's the value of efficiency. But what happens to kind of effectiveness? People we can change outcomes for to reduce recidivism or equity. So that's kind of the overall, and there are many values we can think of, right, that we want to embed in, and we focus on a lot of them. What I want to sort of spend the next kind of 10 minutes on so is a very, it's the first one here, which is the value of fairness. How do we design machine learning AI systems that lead to fair outcomes? And so the approach we take is, step one, the focus of our approach is not just to make the machine learning model fair, but really focusing on the overall system fair, right? And there's a difference. You can make a machine learning model fair, but then if its use is unfair, if you're using it to do outreach programs in English, doesn't matter how fair the system is, the outcomes will be unfair because people who don't speak English are not going to get benefited from it, right? Or you can have the model be unfair and adjust your outreach program, the marketing program, to compensate for it, and you can have a fair outcome. So the idea here is we want to look at the overall system and outcomes, and a machine learning model being fair helps, but is neither sufficient nor necessary to lead to get to fair outcomes. But the overall, there are kind of 6 components here that we care about, right? First is, how do we define what we mean by fairness or equity? And there are lots of sort of philosophical discussions we can get to, but without the definition, we can't build those systems. So we'll talk a little bit about that. Second is, once we've defined what we care about as an outcome, we want to be able to measure how fair or unfair an existing system or whatever you're building now is. So 3 is, we'll most likely find that whatever we've built is not fair. So what are the root causes of that bias? So we understand the root causes. Then we look at how do we improve the fairness, in this case algorithmically. How much can we adjust our system? And we're going to find that we can't always adjust the fairness of an algorithm. But then step 5 gets to how do we mitigate its impact through adjusting interventions that we take. And then step 6 is monitoring and evaluation. So kind of starting from number 1, right, the definition, there are lots of, basically you can define fairness in lots of different ways. And the answer sort of, like, do we allocate equal resources to every group to be fair? Do we allocate them proportional to how large the groups are? Do we allocate them proportional to their needs? Or do we want to make sure that if we don't miss people disproportionately, or we don't intervene on people incorrectly? And one thing that happens is, for each of these, there's a mathematical definition. There's lots of papers and lots of things you can read about that. What it comes down to is we can't achieve all of these things at the same time. That's what we know. And so the thing to sort of figure out is, well, not all of these are equally important for every use. For example, if you're going to help people with, say, the mental health program, if you miss 80% of, let's say, Hispanic people, but you only miss 40% of white people, that's much worse for them than intervening on them disproportionately, right? If you don't need the help, but you're giving them, that's opportunity cost, but missing somebody is much worse. If you're doing something horrible, which you might be doing, let's say you deny bail to people, right? It's denying bail, so intervening on people disproportionately in this case is much worse. So in some cases, like, false negatives are much worse. In some cases, false positives are much worse. So we sort of have a framework we've defined, what we call fairness tree, which helps people figure out, it's not the model or the prediction task that's important. It's what you're going to do with it. So you might be predicting who's going to go to jail, and you might be using it to provide them mental health services. And so then it's an assistive intervention, and you don't want to have disproportionate false negatives. But if you use it to figure out something punitive, then you want to be on the other side. So that's kind of a process we've developed that we use regularly to help people understand what metrics they should prioritize for achieving fairness. Step 2 is measuring and detecting bias. And there are lots of tools that exist. We've built one that's open source. There are many others. IBM has one, Microsoft has one, And essentially, all these tools are fairly simple tools. All they're doing is looking at the predictions that the model makes and measuring error rates, the ones I talked about, false positive, false negative, on different groups, and then kind of telling you you're biased on these groups with these metrics. So that's all of these tools are pretty similar, pretty essential, pretty similar. And the idea is that there's some, so you should be using some of them, and happy to kind of talk more about. But that's once you pick a metric, you can sort of audit your models to see if they're making some mistakes. There are a couple of things that are sort of they rely on. That means the outcomes and the labels being correct, which is an issue, but that we can deal with a little bit. Step 3 becomes understanding the root causes of this bias. And that's because we can't fix it if you don't understand why it's happening. And generally we sort of think about, a lot of people will focus on, well, my models are biased because of data. Data is often a reason, but not necessarily the primary reason. The biggest reason often is the world is biased. The world generates biased behaviors. Our hiring systems are biased, and our healthcare system is biased, and the world is racist, and the world is sexist. So it generates data, perfect data, accurate data, but the data capture is fine. The world has the problem. So that's kind of one source, and then we do things to data. We sample it. We do other things, and that causes additional bias. And then we build machine learning systems and design choices in our system, how we do imputation, how we link data sets together, how that causes bias. And then the interventions we have on that causes bias, right? So we kind of have to break down these pieces, understand what's causing the bias, and then use that to figure out how do we fix it. And so when it comes to fixing, again, like we could fix the world, and that would fix a lot of problems. But there's sort of, let's put that aside for a second. There are kind of 3 typical ways where people work on. One is they fix the data and say, oh, the sampling issue. So maybe, I have not much data about certain types of people. So maybe I can oversample, undersample. They're often called pre-processing algorithms, where they modify the data going into the models. Then there are all these different algorithmic approaches that adjust the algorithms to be more fair, and they're often called in-processing. And then there's a thing called adjust who we intervene on, and how do we select from the people, and those are often called post-processing. And there's sort of, like, I'm not going to go into either, but what we found is that when we actually compare a lot of these different approaches, a lot of them get very inconsistent results, and don't work very well. There are a couple of them that we've found to be extremely consistent. So here's kind of one, and it's not showing up here in the animation, but basically we find that one of the post-processing approaches find that we don't actually have to trade off fairness and accuracy, that we can get both. And happy to sort of give you pointers to some of the work. We compared it across all the different projects we were talking about and many more. And we're finding that we're able to, if we build off-the-shelf machine learning systems, they're always biased. Again, it's not a theoretical result, it's a very empirical result. And we actually build across, tens and hundreds of projects. We find every off-the-shelf machine learning system ends up being biased. But in many cases, we found that if we adjusted the bias, we can actually get that correction. We can reduce the bias to pretty much, minimal, while not losing accuracy, which is both surprising but extremely encouraging. But we have to deliberately design these systems to care about efficiency, to care about equity. And there's sort of some intuitive explanations for why that happens. But again, we've only got a short amount of time, so that's the thing I want people to remember, is that you don't always have to trade off, efficiency or accuracy and fairness. You can actually get both if you're actually designing our systems to do that. And then I just want to end with, some of these misperceptions I see a lot in people trying to build these systems is, the common thing people says, oh, well, not using my system is fair because I'm not using race or gender, or well, that doesn't mean it's fair. Everything is correlated, so you can't really do that. So using race doesn't make our models biased, and not using race doesn't make them not biased. You can't just fix it by fixing your data. At the same time, you don't need to have a perfect unbiased system. You want to be able to compare it with the status quo. How good is the existing system, whether totally human-based or data-based? and that you don't have to want, is it better enough from existing systems? And if it is, it might be worth implementing today while you make it even better. The other piece is, you don't have to satisfy all the measures of bias. Some of them are more important than others. So let's, so spend the time in understanding that. And then the piece around sort of trade-off in fairness and accuracy. Most talks around this topic will start with that assertion, but actually empirically we find that that's not always there. And then the last, couple of pieces of, just because our model is fair doesn't mean that the system that it's embedded in will be fair, and the outcomes will be fair. So we kind of have to evaluate the overall system. And the last piece is there's a lot of work over the last couple of years that has happened in machine learning and bias, and people have been developing methods for reducing bias, but it's still a very new area. So don't take things as given, like it hasn't been tested enough. So just because a method exists doesn't mean it actually reduces bias. So a lot of the work that we've done comparing these methods find that some of them do work and some of them don't work. So make sure you kind of question some of these things, because it's a new area that people are exploring right now. So that's kind of the end of my whirlwind tour. And yeah, I'll kind of pause and if there are any questions, happy to take any questions, but also offline, if people are interested in getting more details about any of these things, happy to do that. So, and there's some links over here as well that you can, there's some more detailed, hands-on notebook, code and tutorials that you can take a look at. That's a little bit deeper than the high level thing I talked about. So.
Thank you, Dr. Ghani. So really interesting talk that I think gets at the very hard but core piece of features and questions that you have to ask in life-critical applications. Things beyond, like Dr. Ghani said, beyond just accuracy, there's so many core pieces of value and fairness and equity that have to be taken into account. So I think we maybe have time for just one or two questions. Are there any questions?
Hi, Rayid. It's Patrick Hall, actually. Good to see you. But I was going to ask, you mentioned getting into the root causes of bias, and have you ever used sort of explainable AI or like post hoc explanation techniques or interpretable models to try to dig into what's causing bias in the models, or is it more of like a human just dig in and figure it out?
So I think the hope of, if the model can just tell me how it's making decisions, I can see if there's something in that chain that could be causing bias. I think that's plausible. It turns out, at least when we have looked at that, the explainable methods are not designed to help us diagnose the causes of bias. And so if they don't uncover anything, doesn't mean that there isn't anything. And if they do uncover something, doesn't mean that that's actually what's happening, right? Because these models, these explanation methods have nothing to do with the actual model. It's kind of imposing often something on top of whether it's chat, whether it's line, whether it's something else. So I haven't found them useful. That doesn't mean that concept is not useful. I think it's just we don't. So what I often tell people is like, if that's the purpose, if you want to design a method that can uncover the root causes of bias, then let's design an explicit method that explains that, is there, here are the things we care about, and here's the thing we want to make sure that we, just like in an audit, just like we do an audit, we don't just run a bunch of things and hope that audit uncovers it. We do a bias audit. So I think that's an open area, is can we design methods that can uncover some of these things, and they may be variations of existing explanation approaches, especially the post hoc ones. But I haven't found the existing ones useful for this task. But I think it's certainly an idea that I think more people should focus on.
Great, thank you, Dr. Ghani. Unfortunately, that's all we have time for today, but appreciate your talk. Very insightful. Thank you.
Sure. Thanks. Sure.